2. Greetings and welcome, ladies and gentlemen. Today we are talking about roots. So roots, you might have heard of square roots before, of real numbers. And you might be like, wait a minute, real numbers? Why do they even have to specify? Are there non-real numbers? Are there fake numbers? And it turns out someday, in a later video, at the end of this chapter, yes, there are non-real numbers. Craziness. As far as you're concerned right now, though, pretty much any number you can think of is real. Okay? So you're probably good. You're probably good. You're good. You're good. You're good. So let's talk about square root first, and we'll define it. So what is a square root? Square root. Root. All right. So for any real numbers, a and b, a little bit wordy here. Real numbers. So there's that real numbers again. Peculiar. A and b. Any real numbers, a and b. If a squared is equal to b, then a is a square root.
Is that easy?
8 is a squared, a to the second power, sorry. I'll make that a loop-de-2 if you'd like. A square root of b. So that's the definition of a square root. Probably not a definition you guys would have had necessarily as your go-to thought on square roots.
Yeah, I was thinking about that. Like THAN.
Yeah, it's supposed to be and.
Than would be a comparative then. I'm pretty sure it's then, if-then statement.
No.
Yeah, I'm good. This
It's
THEN.
this, then that is. It's still
No,
the then.
I'm good. I'm good.
No.
I'm pretty look it up later.
I hope you brought this part out.
What percentage?
I'm pretty sure. I'm like 99.99%. I read a lot of if-then logic and programming, so that's one of the words I'd actually know how to spell.
I don't know.
But anyways, example, if I ask what is the square root of 9, how would you describe that? What is that actually asking us?
What times what is 9?
Oh, perfect.
What times itself is
Yeah, so this is asking the question, what number multiplied by itself is 9, right? That's the question that it's asking. All right, so when you hear square root of something, that's what it's trying to determine. So it's not 9 divided by something. It's more complicated than that. It's what number multiplied by itself is 9. So in case of the square root of 9, what number is multiplied by itself that equals 9? 3, right? And using this definition, you'd be able to justify it and say 3 because, and you wouldn't have to write this on your homework or anything, but it's 3 because 3 squared is 9, right? That's their logic. If 3 squared is 9, then 3 is a square root of 9, right? Or a square root, yes. Yeah, okay, good. Yep, I got that. Or sometimes it'll just be root of 9. So that's good stuff too. So let's talk about some other examples here real quick. What if I want to know what is the, square root of 121? That would be 11. Why? Because 11 squared is 121, right? Perfect logic. Excellent work, my friends. What if I wanted to know, let's see, I don't want to open up a can of worms yet too much, but what if I wanted to know what is the square root of x squared?
8.
Why?
Because x times x is x squared. No,
Because x times x, or because x squared is x squared. Kind of bizarre, but yeah, that works. Right? Technically, there's a little bit more going on here. that we'll talk about tomorrow. That technically it's not just regular old x, but that's fine logic for now. We're good now. What if I wanted to know this? What if I asked, what is the cubed root of 8?
Oh yeah, then you have to like break it up into like 3 square roots of 4 times 2.
Oh, well, eventually we'll do stuff like that if this was, square roots. So the square root of 8, eventually we'll talk about, is the same as the square root of 4 times the square root of 2, which is 2 square roots of 2, is what you're describing. We're talking about the cubed root of 8, however, which actually ends up equaling an integer, a regular old number there. And it's equal to 2 because, what would your logic be, Aaron?
2 times 2 is 4. That times 2 is 8.
Perfect, right? So he's basically said because 2 cubed is 8, or 2 times 2 times 2 is 8, right? And that's what I want to talk about next is what is an nth root? Nth root. Okay? And it's going to be a similar definition of what we had earlier. 4. Yeah, nth root. Yep.
What number is
It's real line.
Think of a number and call it n. And in fact, actually, we will restrict n somewhat. It can't be any number. We're going to make it a positive integer. But for any real numbers, a and b, and any positive integer n, if, actually I guess I'll stand that with a period, if a to the n equals b, then a is an nth root of b. I'll write that down there. Nth root of b. It's kind of weird, but it's the same logic, and technically you guys had applied it perfectly up top there. Let you finish writing. So when I saw, actually before I do my next example, when I saw the cubed root of 8, what that was actually asking was what number multiplied by itself 3 times, or a total of 3 times, is 8. And when I say 3 times, I meant there was 3 factors being multiplied. Technically, only 2 operations of multiplication were occurring there, right? So I could say, it's hard to try to put English words to some of these questions, but as long as you know what I mean by that, I think we're fine, right? There are 3 factors of a single number that is 8. What is the number, essentially, is kind of what it's saying, but that's less intuitive of a statement, so it's not as helpful. What if I wanted to know this? What do you think this means? Actually, that. There. How do you think you'd even read that? 4 roots of 16 would technically be 4 times the square root of 16.
or square roots of 16?
4 square roots of 16 is technically still that.
4
to
root
the
16.
The 4th power root of 16.
Close. This is read as the 4th root of 16. All right? So we had the cubed root. We had a square root. Now we've got a 4th root. And in fact, anything bigger than 3 doesn't have a special name. I could have the 5th root, the 10th root, the Googleth root, right? I could kind of have a pith root, which is weird, except that wouldn't quite fit our current definition, right? A being there. Because I restricted n as being a positive integer. Integer means that it won't have a fraction or decimal component to it, right? So, fourth root of 16, let me just get you some vocab here. The 4 part is actually called an index. The index of the radicand, if you really, or the index of the radical, if you really wanted to. The 16 part is called the radicand. And the entire expression is called a radical. Okay? Radical always makes me think of the Ninja Turtles. It wouldn't have been Splinter's favorite word. His, of course, was cowabunga, but that's all right. I think Raphael liked radical. I don't remember. So, the fourth root of 16 is asking what question, do you think?
What times what equals 16?
Sure, right? What number multiplied by itself 4 times, right? There's 4 numbers being multiplied, is 16. And what number do you think that is?
2.
Happens to be 2 again, because 2 to the 4th is equal to 2 times 2 times 2 times 2. 2 times 2 is 4, times another 2 is 8, times another 2 is 16. Bam. Right, so that's the y, but this is my answer. So, interesting stuff. Now, what if I wanted to know, let me ask you this question. In the case of a square root, what is its index? So back up here, when I asked the square root of 9,
2.
what do you think the index would be? What number goes here?
2. 3.
Why 2?
2, because like 1's 3, there's 3 numbers and they directly 8. There was 4, it was 4, it was 2.
It turns out it is 2 for that reason, right? Because he said when there was 3, it was 3 numbers being multiplied. And here I'm talking about 2 numbers being multiplied or squaring. This number and this number are the same. And what I want to point out about the square root is that the 2, all right, in the land of roots, 2 is your hobbit, all right, where you don't have to write it for square roots. It's just implied. So there's an invisible 2 as your index for all of those. All right? So that's kind of a sneaky little 2. What would it mean if I had a 1th root?
It must be 1 times the number.
Yeah.
It's 9 times.
Could I square
Or no.
Like if I asked you what is the 1th root of 10, I'd be asking what number is 10? And it'd be 10 because 10 to the first power is 10.
So without the 1, the square root of 10.
It's
No.
Without the 1, it would mean the square root of 10, and that would be around 3.1 or something like that. So this is a 1th root of 10. We never write, yeah. If it was the square root of 10, that would be about 3.1-ish.
3.33.
No, that because 3 times 3.3 repeating is 10. You're thinking of 10 divided by 3,
Yeah.
right? But I'm asking what number multiplied by itself 3 times is 10. What is 3.1 to the 3rd power? No, wait. Oh, guys. Wait a minute. Why did I say 3rd power? I meant squared. Silly me. Oh, silly me. I get 9.61. So I'd be close. So it's probably, maybe is it 3.2? 3.2 to the 2nd power is 10.24.
Why don't you just say the square root of 10?
So 3.15.
Why don't you just do
Or,
that on-
better yet, most accurate is the square root of 10. And it turns out there is actually a way to calculate that. But this idea of estimating is still valuable. And actually, at some point, I do have to show you guys that as well. I guess I could show you how to do a square root right now. Let me, so yeah, if I wanted to figure out, let's see, is this starting? Oh, here we go. It's starting up, I hope. And do I have any video? No? Oh dear, don't crash on me now. All right, whew, here we go. All right, so if I want to calculate a square root on a calculator, and let's see, is it focused? Yeah. All right, what I would do, actually I can full screen this a little bit more for the sake of our viewers at home. What I could do is notice that I've got this square button here, and right above it is a square root symbol. All right? So to access square root, I would hit second, and then the square button, and that opens up my little square root right there, right? See that? And then I could type 10, and I will get the calculator's approximation out to probably like 8 decimal places of what the square root of 10 is. Okay? Now, it turns out you can also do cubed roots. To do that on this calculator, you have to hit the math button, and that opens up a menu. And under the math menu, you can see a cubed root option, and I also have an xth root, which would be like my nth root situation. So for instance, if I want the 4th root, I would do 4, hit math, pull up the xth root, and the 4th root of 16, friends, is 2. And why is that true? Because 2 to the 4th power is 16, right? So there's a little bit of calculator input understanding on how to do some of that. So yeah, 1th root is not something we'll ever ask because that's just kind of a weird thing to ask. Because it's kind of like this, right?
Are Texas Instruments actually made in Texas?
I think they used to be. Actually, Texas Instruments was also responsible for developing DLP technology, digital lens projection, which a lot of LCD projectors as well as rear projection TV sets back in the day had them. And digital lens projection was literally every pixel on your screen is a very tiny mirror that is pivoting either towards or away from light and reflecting it out through the lens and onto the screen. So if you have a 1024 by 768 screen, you would have to multiply that, and that would have been the number of mirrors that you had.
Is this still recording?
Yeah, it is, but that's okay.
Oh my god.
432. So that would have been the number of mirrors in that screen, and that's not even that high resolution of a screen. But that's the resolution of my projector here. I don't think that's a DLP projector, though, anymore. I don't remember. But anyways, side notes. Let's keep talking about radicals. Let's stop poking each other, too, friends. What if... Oh, okay.
Can you define the brightness of the calculator screen?
A little bit. It's not a backlit screen. I can change the contrast of it. It's more specific. So if I want to know, what about the cubed root of negative 27? What are your thoughts on that? What is that asking us?
What times
What times what equals negative 27?
Right. Can that even exist?
No, it's negative and that's positive. Right?
Well, let's see.
Oh yeah, it can.
What cubed would equal negative 27?
Negative 3.
Well, think about it. Negative 3 times negative 3 times negative 3. These two minus signs would become positive, but I'd still have one left. And that actually could work out. So, in this case, it is possible to have a cubed roots can have negative answers, which is interesting. Interesting stuff.
Only cube roots, though, right?
We'll see in a moment that they're not the only ones. But square roots, let's ask this a similar question. What if I want to know what's the square root of negative 4? What are your thoughts on that? What's that asking us?
3
Times
2.
Yes, negative 4, but that
Negative 2.
And if you try negative 2, well, negative 2 is negative 2 times negative 2. And that's, oh no, that's not right. Maybe it's positive 2 squared? No, that's just positive. That's not right. What I'd need to do is negative 2 times positive 2. That equals negative 4. But this, I think you guys would agree, is not squaring because I'm not multiplying it by itself. That's an entirely different number. So it turns out this has no real answer.
So only if it's cubed it does? Only when it's cubed it has an answer?
well, we'll see in a moment. Not just cubes can have roots of a negative. Well, that's not necessarily true either.
This is for the odd numbers.
It will, yeah, it's actually going to relate to the, I don't think I have a word for this. The audacity,
Yeah.
that's not an actual word, or the evenicity. Yeah, not this word, not audacity, if I spelled that right. But I was referring to the audacity, right? So if I have an even index, right, in the case of 2, right, I then would have an even number of things being multiplied and an even number of negatives, and that would always come out to be a positive. If I have an odd index, then I have an odd number of things being multiplied, and some of them, all of them, many of them would pair up, except one would always be left over because it's odd, right? It doesn't have a pair. It doesn't come in pairs because it's not even. And then I could end up having a negative outcome. So it has to do with the index being odd or even.
So if you have a negative outcome, then the number inside the parentheses has to be negative. Correct?
Not necessarily. Let me actually talk in more specifics right now. Let's say, what if I have the square root of 64? What's that equal to? 8. Now, 8 is actually referred to as the principal root of 64. Because I don't know if you realize this, there's actually 2 answers. There are 2 roots of 64, 2 square roots of 64.
Negative 8.
Negative 8 also works. Because notice, negative 8 squared is negative 8 times negative 8 equals 64. And by definition, all the way back up at the top, if that's true, then that is a square root of b, right? So therefore, negative 8 must be a square root of 64. I would refer to that as the negative square root. The principal root of a number is always going to be, well, at least of an even root, will be your positive number. So it's the primary one that comes out. So if I wanted to refer to the negative root, I would have the negative square root of 64, and I'd be referring to its negative root, which is kind of weird. If I wanted to refer to both, then I would actually write plus or minus the square root of 64, and that would give me plus or minus 8. Or I could write it as 8 and negative 8. And actually that plus or minus in the formula you're talking about does come from a square root. So that's why there is a plus or minus there in that formula. So, so interesting things there as well. Whereas the cubed root doesn't quite work out. So if I have the cubed root of negative 27, this is the principal cube root. Okay. So let's talk about some of our limitations. Let's consider real roots here. I'm going to actually... Yeah, come on, friends, come on. So here's a little chart that I want us to analyze.
I don't understand negative root of 64 and equal negative 8. It can be equal to positive 8 as well.
Well, the notation that we use when I have a minus sign and I'm just asking you to evaluate something,
Yeah.
I'm specifically asking just what is its negative square root.
Oh yes, the principal one.
Yeah, so it's just a weird notation there. If I was solving an equation,
You can say both.
let me fit this in here real quick before we analyze this table, just because we had the question come up, and that's fine. If I was solving an equation, and I said solve this, and I said x squared equals 64, how would you solve that equation? What's the inverse operation of squaring?
X would be 8.
How do I undo squaring? It turns out you square root,
Yeah.
right? So square rooting is the inverse of squaring. right? Cubed rooting is the inverse of cubing. And when I square root both sides, if I'm solving, when I square root both sides, I actually instantly have to add the plus or minus. And then I would have x equals plus or minus 8. So I'd have two answers in that situation. But if I'm just evaluating something, if someone just says evaluate and they already gave you the square root of 64, then they are only interested in the principal root. So it's a weird subtlety there, but it does come into play with a few things that we'll be doing, so be aware of that. So let's analyze this table real quick. So if I have an even index of a positive number as my radicand, it will have one positive root and one negative root, like plus or minus 8, right? If I have an even index of a negative number, it will have no real roots, like when I tried to do the square root of negative 4. Okay? If I have an odd index, like my cubed root, of a positive number, it will actually have one positive root and no negative roots. Okay? So it has no negative roots. So when I asked earlier what was the cubed root of 8 up here, you couldn't have told me that negative 2 was a cubed root of 8. Because negative 2 times negative 2 times negative 2 would give me a negative 8. All right? So an odd root only has one answer at a time. If I have the cubed root of a negative, like in the case of the cubed root of negative 27 here, I have one negative root and no positive root, because 3 times 3 times 3 is not going to equal negative 27. Right? So it turns out for odd indexes, your answers, you'll only have one answer at a time. Okay? And then if I take a square root of 0 or an nth root of 0 for any number, right, the square root of 0 is 0 because 0 squared is 0. The 7th root of 0 is 0 because 0 times 0 times 0 times 0 times 0 times 0 times 0 is still 0. Right? So rooting zeros will always end up equaling 0. Okay? So let me do a couple more examples, and then I think we'll call it a day for this video. Let's see, we did that little thing. Yeah, there's a lot of stuff, and we're actually going to cover a little bit more on this tomorrow, talking about some absolute value stuff. What if I want to evaluate this? What is the square root of 49 x to the 8th power? It's okay, don't be scared. Now, one of the ways I can do this square root would cancel out with something squared, right? So what could go on the inside of this? 7 squared is 49. And x to what power? X to the 4th squared would be x to the 8th.
And that's it?
Well, I'm not done. This square root would then cancel out with the square, and I would get 7x to the 4th. The square root and a square. Yeah, those are inverse operations of each other. Okay? It's kind of interesting stuff there. And tomorrow we'll see some more little things at play here.
Tomorrow we don't have any.
Oh yeah, the next video. Another way you could do this, I actually might have broken this up into the square root of 49 times the square root of x squared times the square root of x squared times the square root of x squared times the square root of x squared. Here's another weird way you could think about it. Square root of 49 is 7. Square root of x squared is x. Square root of x squared is x, x, and x. And then if I simplify that all out, I get 7x to the 4th. All right, so there's kind of a few ways you can think about it. And we'll actually even learn some other tricks later. We'll learn some other tricks later. Let's actually do this example. What if I want to figure out what is the square root of 25x to the 5th? Now this one's... No, we're going to do this together.
How we're gonna get the 5.
Exactly, because I don't know how to cancel out a square root with an odd number.
It'd be 5 square root x 5.
So watch, I'm going to break this up into the square root of 25 times the square root of... Now, what is the largest even number that goes into 5? Not dividing, but like 4. I could rewrite this as x to the 4th times x to the 1st, right?
Yeah.
And I do know how to simplify an x to the 4th,
Yeah.
right?
Yep.
So let's see, square root of 25 is 5. Square root of x to the 4th, what do you think that's going to be?
X to the second.
X to the 2nd. How do you guys know that so quick? And then this square root of x is in there. How did you know that the square root of x to the 4th was x squared? Could someone give me a verbal explanation for that?
X squared times x squared is x to the 4th.
Because x squared times x squared is x to the 4th, right? So a side note, right, the square root of x to the 4th, you could have thought of as the square root of x squared times the square root of x squared. Right, so that was x times x, or x squared, without a radical at all. So in the case of an odd exponent, and you're taking an even index, you just want to try to break it up into as many as you can. Let's see, how about one of these?
Did you just have x square root of x because you couldn't simplify x to the first anymore?
Right, because x to the 1st, I'm trying to take an even index of an odd exponent, and I can't break it up anymore. Perfect question. Let's see, last example. What if I've got the 5th root of 32, x to the 10th, y to the 15th?
That's an easy one.
Oh,
Easy one?
first choice.
It'd be the square root of 32 x.
The 5th root of 32.
Yes, sorry. You have to go 32 times x.
Why do we get 32?
Oh, you're gonna break it up. Okay, 5.
Oh,
Could I think of x to the 10th as some number of x's to the 5th?
Yeah.
What would go here?
2.
Right? And then,
X to the 3rd times
and that would be y to the 3rd to the 5th. You guys see that?
So it'll be x squared times y to the 3rd times 5 squared to 32.
X squared, y to the 3rd I agree with, because the 5th root and the 5th powers cancel out. Does anyone know what the 5th root of 32 is?
2.
It's 2. Yeah, because I'm going to even, if you wanted, I happen to know that off the top of my head, but it turns out 32 is the same as 2 to the 5th. Because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And that was 5 of them. So this would actually be my answer here. So there's some interesting things you can do. Actually, does anyone see a shortcut? How does this number and this number relate to giving me this number?
Oh, that's what I was trying to do for you. Just
Divide.
Divide.
Right? And this number, how did those give me that number?
Divide.
Divide, all right? So do you see that relationship there? So there are eventually some other shortcuts that we'll be learning as well.
what is our homework?
All right. Have a good day, Internet friends.